Hi, Honors Algebra 2. This is Miss Craft. Today we're going to be doing lesson 11 for greatest common factor and factoring by parts. So our objective is to solve quadratics by factoring by parts and by doing greatest common factor, or GCF. What you should have done before this is kind of had some experience with quadratics and what zeros mean and where we find them on the graph and what a quadratic looks like. So this will be the algebraic piece of this before we learn actual factoring when a is equal to 1 and other numbers. So factoring with GCF. What is GCF? Let's recall what this means. So when we list all the factors of 24, right? Remember these little tables we did when we were little babies? We would do, well, 1 and 24 multiply together, and 2 and 12, and 3 and 8, and 4 and 6. And then 4 and 6 are really close, so the only factor we have between there is 5, and it doesn't go into 24. So then we do the same thing over here, 1 and 18, 2 and 9, 3 and 6, and then we have 4, which doesn't go in, and 5, which doesn't go in. So here we have these two greatest common factors of 6. So 6 is their greatest common factor. It says to list the factors of 3x squared and 6x. So we're going to do something similar to what we just did up here. We're going to say, well, 3x squared is here and 6x is here. What can we multiply together to get to 3x? Well, we can multiply 3 and x squared, right? We can multiply 3x times x, and then we could multiply 3x squared times 1. How can we separate 6? Well, we could do 6 and x, right? We could do 6x and 1. We could do 2x and 3, or we could do 3x and 2. Okay, those are all the factors. So when we look at what the greatest common factor for these two is, we see that we have a 3x here and we have a 3x here. And so therefore we'd be able to divide both of these by 3x. Okay, so just a little review on that. And I understand that this piece is probably new for most of you. So again, listen to this video, pause me as much as you need to, and make sure to ask your teacher questions during synchronous learning time. Oh, did I skip a page? No. Okay, so factoring is a verb. It's the decomposition of an object into a product of other objects or factors, which when multiplied together give the original. So factoring is the opposite of distributing. So before we have learned that 3x times x plus 2, well, we just distribute. Remember this little rainbow method? Well, here we would get 3x squared plus 6x. Great. Here, when we go backwards, we want to divide both of these items by the same thing and the greatest thing that we can. So they both have an x, so let's divide them by x. And they both are divisible by a 3, so let's divide them by 3x. Okay, so when we divide 3x squared by 3x, we get x, right? That's the only thing left over. 3 divided by 3 is 1. X squared divided by x is just 1x left. Now, when we do it to 6, we do 6x divided by 3x. X over x is 1, so it leaves us with 2. And that is why they are equivalent. So you can always check your work and go backwards by distributing when you're not sure if you factored it correctly or not. Okay, so factor the common term out. We're going to do these together, and then we have some practice after this. So what can I factor out of 16 and 8? 16 and 8 have the greatest common factor of 8. So we're going to divide this whole thing by 8 for sure. And then we have 1y here and 2y's here, right? This really just means y times y. And so we can definitely divide both things by 8y. So we're going to take an 8y out, or divide an 8y out. And now we have 2y plus, well, 8y divided by 8y is just 1. Okay, and if I'm not sure about my answer, I can always FOIL it back out, or in this case, just distribute it back out to here and get the same thing up here. Okay, so if you want to pause me at this point and go ahead and try it on your own, I think that's a great idea. If not, here we go together. So the greatest common factor, 15 and 5, I can see that's 5. And then I've got an x squared and an x. Well, the most I can take out is an x. and y to the third and y, the most I can take out is a y. So 15 divided by 5 is going to leave me with 3. X squared divided by x, I only have 1 x left. Y to the third divided by y, I have 2 y's left. And then minus 5xy, well, that's just 1. Okay? Again, distribute this back out if you need to. And just as a side note on here, I just want to show you something. So when I'm dividing x squared by x, it literally means that I have 2 x's on the top, x times x, and an x on the bottom. And we know that when we have multiplication, we can think about this being 1 over 1, which just leaves me with the x, which is how I got x here. I know that's always a question we have. Next one. So now we have 3 terms. We've got to think about 3 things. The first thing is our coefficient. So the biggest coefficient we could have, we can't divide them all by 12. We can divide them all by 6 though. So let's divide them all by 6. And then the biggest exponent that I have is a 5 and the smallest is a 3. So let's take out x to the third. Okay, so we're going to take out and put it out here, 6x to the third. But when I do that, 18 divided by 6 is 3. X to the fifth divided by x to the third, that just leaves me with 2 x's. And then 36 divided by 6 is 6. And x to the third goes away. And then we have 12 divided by 6 is 2. And then x to the fourth over x to the third. So again, x to the fourth over x to the third. We have 1, 2, 3, 4 over 1, 2, 3. So we cancel them out, and I'm just left with an x. Okay, so again, FOIL this back out if you can. And we can't combine any of these because one has an exponent of 2, one just does not have an exponent, and then we have just a constant. Next, go ahead and pause me. I'm going to pause myself. Write down the problems. Try and do them on your own. All right, so we're back over here. Here are the answers for these ones. As you can see, they're not in correct form for a polynomial, but that's okay. We're going to learn all of this later. So just do your best at finding the greatest common factor on these. Pause me if you need to take more time. All right, so now we get into our second topic, which is factoring by parts. To factor by parts, you group the terms into pairs, then factor out the GCF of each pair separately. So we need to know how to do GCF in order to factor by parts. Looking at this one here, we split it into two separate forms here. So we've got the greatest common factor of these two, and that's going to be 2x squared. And that leaves us with a 2 and an x inside here. And when we factor out a 2, 6 divided by 2 is 3. And x squared, well, that is on the other side and it goes away. Okay, now when we talk about our other side here, we have just one that we want to factor out, right? Like we don't need to factor anything else out because it can't get any smaller than that. So we don't factor anything out. So what I want you to notice here is, just like in algebra, if we have 5a plus 10a, what that really means is we have 5 times a plus 10 times a. And what we can do with those, because they're multiplied by the same thing, is combine them, and they become 15, right? 5 plus 10, 15a, right? It's a common term. So what we've actually created over here is a common term for our factoring by parts. So when you look at this, we can say, well, we've got 2x squared, but then we have this common term of 2x plus 3. And then, yeah, we have this plus 1, but then we have this common term of 2x plus 3. Okay, so basically what happens is we can add this one plus this one with our common term of 2x plus 3. So we have 2x squared plus 1, which is just like our 5 and our 10, like I just said, but we can't combine these. Okay, so we can't make it nice and say 15. It has to say 2x squared plus 1. And then we have our common term, 2x plus 3. So there's a lot of questions every year about why isn't it 2x plus 3 squared, or why isn't there two of them? It's because it's a common term. We're adding them, and they make these two things like terms. So we can add this term plus this term because they each are multiplied by a 2x plus 3. Okay? So there we are. They wrote this one first and the other one second. But now what we can do with these, instead of, I mean, it is a form of distributing, but we have to remember that it's FOIL, right? First, outside, inside, last. So we multiply our first ones together. We multiply our outside ones together. Then we multiply our inside ones together. And then we multiply our last ones together. So when we do that, we should get back to this guy right here. So I'll go ahead and show that to you right now for any of you that have not seen it. So we'll get 4x to the third as our first term. Then we add our outside term in there. So outside would be 2x squared times 3. So that's going to be 6x squared. Then we have our inside, that's 2x, and our last, which is 3. Did we get back to where we started? Yes, we did. So check, we did it right. This guy is our answer. Okay, so here's some practice. I'm going to walk you through these two examples, and then you guys can pause if you feel like you've got it already, and then we'll do a couple more examples at the end. So here we go. If we want to break these two things apart into two separate forms, here we have 5mk plus nk. Well, the common term in this guy is just going to be our k. So I'll take out k. What that leaves me with is 5m plus n. Okay, and now I have my other terms over here. What I can take out is a 2 and no variable. So 10 divided by 2 is 5, and I'm left with the m. And 2n divided by 2 is n. So I'm left with the n. Notice we still have our common term here. So we can add this k plus 2 because these two things are the same, and they have to be the same for us to be factoring by parts correctly. Okay, so we'll have k plus 2 times 5m plus n, and we have factored by parts. Okay, now you can FOIL these back out first, outside, inside, last to check your work. I'm going to go to the next one. Okay, first two terms, and then we have our second two terms. Pay attention that this is a minus sign right here, and it actually goes with our second terms. So we can take a 2 out of the first ones, and we end up having 2 minus q. Okay, we can take a negative, right? Because we want to leave a minus sign in here if we want it to be like this. So if I want this to be a subtraction sign, then I need to take a negative out. And I want my first term to be positive, and it's negative right now, so I know I need to take a negative out. And again, now we can take out a 3p. 6 divided by 3 is 2, and I have no more p. 3pq divided by 3p, that just leaves me with q. So now again, this guy is the same as this guy, and I can indeed combine my 2 minus 3p together because they are like terms and they're both multiplied by 2 minus q. Okay, so then here is our factored answer, and again we can FOIL this to check our work. All right. I'll walk you through these last two, and then you guys will have some practice at the end, which I'll just show you the answers to, and you guys can pause me before I show the answers. So this one here, we've got the first two terms here, and then we're going to work with the second two terms over here. So the most I can take out is an r squared, and that leaves me with r plus 3w. The second one I want to be r plus 3w, right? So some of you will work better working backwards like that, and that's totally fine. How do I get this second set of parentheses to equal r plus 3w? Well, I see I have an r over here, so maybe I want to pull that out to the front and rewrite this as minus 3rt minus 9tw, right? Because maybe they mix those up. So now I would want to leave an r here, so I know I have to take out a negative 3t. That leaves me with r. I know I want a 3w here, so if I take out the negative 3t, that actually does leave me with 3w. Okay, so you can work backwards like that. And again, we have like terms, so that allows us to do r squared minus 3t times r plus 3w. Questions on this one, write them down so your teacher can answer them. Again, first two and second two, pause me if you need to. We're going to take out an m squared, and we have m plus 4. And then we're going to take out a negative 6, and then we'll have m plus 4. So because these are like terms, I can combine my m squared minus 6, and I can have m plus 4. Okay. Here are the next set of problems. Go ahead and pause me, and then I will show you the answers at the end. All right, so here are the answers to the last 4. Make sure you write down the problems or the numbers so your teachers can go over this with you in class. All right, and we'll see you all there.